Welcome to the session on Introduction to Analog Circuits. These slides were prepared by undergraduate student Winter Chen, and I will be presenting them. So first we want to talk about what is electricity. Electricity is the flow of charge from one point to another. Electricity, as you know, is what allows us to have light in our house and allows us to cook food on an electric stove. Electricity has three major properties that we like to measure and understand. The first is current, which is a measurement of that flow of electricity. Basically, how many charges per second are passing a given point. The second is voltage. This is the potential difference between 2 points. Basically, it's a measure of how much energy charge has by being in a certain position in the circuit relative to another position. One important thing about voltage is that it's always a relative measurement. We only care about the voltage difference between 2 points when we're talking about a circuit. And the third important parameter is the resistance. The resistance is the opposition to current. There are devices known as resistors that limit the flow of current. The units for these parameters, current is measured in amps, voltage is in volts, and resistance is in ohms. It's the Greek symbol for omega. Let's dive in a little bit and look at some of the resistors. First, resistors are manufactured elements that are color-coded. Typically, they're wire-wound carbon film or other materials, and they're color-coded to indicate the value of the resistance. This color coding is necessary because it is very difficult to write the actual numerical values of the resistance directly on the part. It's difficult to do it at low cost. So these resistors, some of them will have 3 bands of colors, some of them will have 5 bands, some have 4. The number of bands really just determines how to interpret them. The last band is always the tolerance. And the second of last band is always the multiplier. So the last band is the tolerance, the second of last is the multiplier. So the way that we interpret this 4-band code, so a lot of the resistors have 4 bands, we have to orient the resistor first such that the tolerance color is on the right-hand side. And typically you'll have gold as the right side, as the right-handmost color, which is 5%, plus or minus 5% tolerance, meaning that they can make the part and it may be the value, or it may be the value plus 5% of it, or it might be minus 5% of it. Other common colors for resistors for the tolerance band are the 10%, or there may be some that are brown for 1%. But the majority of ones will be gold for 5%. So let's say that we've organized the resistor in this manner. So the gold tells us that this is a part that's manufactured to plus or minus 5% tolerance. So sometimes the parts will be slightly lower or slightly greater. The second of last band is the multiplier. So the multiplier just allows us to represent a very wide range of resistances with a single color. So black is you take the value and you multiply by 1 ohm, brown is you multiply by 10, and so forth, going all the way down to white, which is a gigaohm. There's also gold, which means you multiply by 0.1 ohms, and silver, which is you multiply by 0.01 ohms. Okay, so now we're going to analyze the other bands. So in this case, this is a 4-band case. So we're going to look at the first band and the second band, and there is no value for the third band. So we're only going to consider those 2 numbers. So in this case, the first band is green. So we keep track of the number 5. The second band is blue. So we keep track of the number 6. So right now we have 5, 6. And then we're going to multiply 56 by yellow, which is 10 kiloohms. So 56 times 10 is 560. So this resistor has a value of 560 kiloohms, and the tolerance is 5%. What about this resistor? So again, the first step is we need to orient the resistor such that the band for the tolerance is on the right-hand side. Normally there's a non-uniform spacing where you can tell that there's slightly more spacing to the right-hand side that allows you to orient it. So in this case, the tolerance band is brown, and so brown is plus or minus 1%. So this is a high precision resistor. Its value is very close to the desired value. Okay, so in this case, this is a 5-band code. So what we're going to do is we're going to look at the multiplier. The multiplier is black, so it's 1. And then we're going to read the 3 digits to get the first 3 bands. So the first band is red, so that's 2. The second band is orange, so that's 3. The third band is violet, so that's 7. So we have 2, 3, 7. So 237 times black, which is 1 ohm. So this is 237 ohms, and the tolerance was 1%. So go ahead and look at this resistor and figure out what the value of the resistance of this resistor is. Okay, so let's discuss what you found. So you should notice that the first band is brown, which is 1. The second band is black, which is 0. The third band is the multiplier because it's the second of last band, so that's blue, so that's mega ohm. So we have 1, 0, or 10, and then blue, mega, so we have 10 mega ohms. And then the last band is gold, so that's plus or minus 5%. So now go ahead and look at your circuits 1 part list and see how the colors that were written there agree with the values that are on your resistors. Okay, so moving along, let's now talk about Ohm's law. Ohm's law is a fundamental law of circuits that allows you to figure out the relationship between current, voltage, and resistance. What it states is that these things are proportional to each other. Basically, the voltage necessary to flow current in a circuit is equal to the current in amps times the resistance in ohms. So voltage is equal to current times resistance. In analogy to the water pipes, so some people think of a water flow through pipes as an equivalent to circuits. So imagine that we have a water system. So we have this outdoor pond and we're pumping water through these pipes. The voltage is the water supply. It's sort of the amount of pressure that can be applied by the system. The wires in the circuit are equivalent to the pipes. So there's water flowing through the circuit, or there's water flowing through the pond, and this is equivalent to charge flowing through the circuit. The current is a measure of how fast the charges are moving, and so the analogy would be how fast is the water flowing in the pipes. And resistance can be thought of as clogs in the pipes, or it could be thought of as very small diameter pipes. It's very hard to push water through pipes when the diameter is small. So Ohm's law states that the voltage is equal to the current times the resistance. We can invert this relationship and get that the current is equal to the voltage divided by the resistance. This is useful for being able to estimate current flowing in a circuit by just measuring voltages and knowing what the resistances are. Equivalently, we can find the value of a resistance by measuring the voltage across it and the current flowing through it and dividing. The resistance is equal to voltage divided by current. So some people joke that there are Ohm's 3 laws, V is equal to IR, I is equal to V over R, and R is equal to V over I.